All right, today we are going to do some fine tuning on the new GPT-OSS smaller model. We will essentially, I think, just to go through like some different things that we need to do with this model. One, we need to like prepare a data set. Maybe if I use Figma, I can show you what I'm going to actually need to do. Let's open up FigJam. Make this bigger. All right. So first we're going to prepare a data set. Then after we prepared the data set, we're going to prepare the model. And this will be like tokenizing the setup of the tokenizer. Load the model on the GPU. Then we'll do the fine tune. Then we'll run inference again. We'll probably just run influence on the other one too. Let's move this up. Okay, hopefully this makes sense for the steps that we're going to do today. And yeah, we're going to do this with a, let's take a post-it note, a H100, I'll use one, and our goal is frankly just to learn more about fine-tuning the GPT-OSS model. Wait for it to start and then, let's see. Notebook on port. What port was it? 5432. Oh yeah. Let's see. How do I connect to this machine? What's the IP address? Oh yeah. sec. Tree. No available upstream, but I don't remember the port name. Wonderful. I gotta figure out how to do this. Let's terminate this one. I just don't remember the port that I used. Pretty sure it was at 5432. Hyperbolic Jupyter notebook. Huh, sick. Okay, so let's terminate this one. Rent on. Port 888. Should start, and let's see. That's low. Forever. What do you do? Oh, okay, perfect. All right, let's load this one up. Connection closed. Weird. All right, wonderful. Okay. Sometimes it works, sometimes it doesn't. So weird. Okay, now I need to figure out the name of my machine. In a new to copy and paste there once again, but modify to include. In a new terminal, copy and paste the SSH commands once again, but modify. Oh crap! No, so. -L. Alright, that says open collab top right connector local runtime file new notebook and go to where do I go? Like on the top right, connect to local runtime. Sweet. What? All right, looks like it's connected. Now, let's go ahead and get cooking. So to start with, let's install some dependencies. It's going to take a while to run. Let's log into Hugging Face. We're probably going to need, I think I have a token in here, but I think it might be old. This is a cool guide. Didn't know you could do that. We'll call this GPT-OSS fine tune. Okay, so there's a couple of things we want to do. We want to prepare the data set is one. Next thing that we are going to do is prepare the model. Prep the model. After that, we will save the model and push to Hugging Face. And then following that, we'll run inference. Okay. Looks like that ran. Let's go log in. Okay, let's just install this. I'm just going to put it up here because it's just easier. Okay, looks like that worked. Okay, so with the data set, the next thing we're going to do is we're going to use this. Oops. I think we'll use this data set, right, which is like this like multilingual thinking. It looks like it's got like a bunch of different languages in here. Doesn't look like it has. Actually, let's see, what languages does it have? Does it say? Got it. We'll see what languages it has in a sec. Because if I can find my mouse, we're going to use it. So we'll get the data set and put it in. And then I'm going to ask group by the reasoning language. See how good Gemini is. It takes forever. It's the first thing I'm realizing. But that is pretty good. Let's see. Now to load the tokenizer. From transformers, and then let's get the model. We're gonna get the smaller model and tune that one. Then we're going to apply the format they use, which is this like OpenAI format for the messages. Okay. Okay, so this is an example of one that we got. Okay, next we need to prepare the model. So we'll import Torch and this mxfp config. We will set dequantize to true, and then here's some keyword arguments for the model it will use. And then this should load the model on our machine. Take a while. Okay, while that runs, let's run some inference right now. Once this loads, sorry, I'm just going to try and clean this up. Prepare the data set, run inference on the model, save the model, run inference. Okay, let's let that run. Okay, let's see if we can just get some responses. So you'll see this looks like pretty similar to the to a message. This is basically asking what the capital of Australia is. Here we get this like output. And it says the correct answer is Canberra. Provide the answer in Spanish, and it says La capital de Australia is Canberra. Okay, so let's see how much we can sort of fine-tune this now. So to start with, we're going to use this library called PAFT. Let's do some fine-tuning. No, not going to run inference before training. We will delete this. Run PAFT. Set up LoRa, and All right, now let's get the path model, set it, and let's print the params just to see. Oops, what did I do? Did I hide it? Yeah. Okay. So it gives us some more information about the model. Let's print the. So this has the 20 billion parameters. It's and yeah. All right. So next up, we need to do the fine tune. Fine tuning. All right. How do I find some code? All right. This we're going to use TRL. And set some args for the training. To set the learning rate, the max context length. We're going to use this company track.io to report the training results out, so for us to be able to see it. But we could use anything else. All right, with that, I'm going to run this and train it. It's going to tokenize the training set, truncate it, and then run it. Unauthorized. Okay. Let's do this. Access tokens. And make sure you can't see it. Okay. Okay, let's see if this works now. No. What is going on with this? It seems like there's a Hugging Face error, but maybe I can set the token. Oh, here we go. Like, what are they doing here at Google? That's what I would love to know. That is why. Alright. So what I need to do is just pull this out because it can't access the token. And here, let's see. Pull this back. Nope, doesn't like that yet. Alright, I think this is going to work now. Nope. Unauthorized. Pretty permitted access token from what I can remember. Why do you not work? Token. Alright, so now it seems like I can also go here and run this. Maybe. Let's see. So it looks like this is going to go train. We'll leave this train for a bit. Why I can't see that. Normally you could see the training graph on it. Alright, this is gonna run how many steps did I add? It's gonna take a while. Alright, I'm gonna go get some food. We're getting there. It's almost at 63 now. Let's see. I'm getting close. Alright, let's write this other code up. Trainer dot save model. Alright, 3 more to go. 2 more rounds to go. And we should be good. All right, looks like we have our training done. Let's go ahead and push this. Okay, looks like it's been pushed. That's cool. Oh yeah, now let's run some inference on the model. Let's clear the GPU to avoid out of memory. All right, now we can run inference. Get the tokenizer. Then load it. Merge it together. Thought we cleared it. Okay, let's try and just restart it. Looks like it's restarting, maybe. Let's find out. Interesting. What was the guide again? It's like let's see, let's p-kill this. This is annoying. I don't know how. Wonderful. Connected. Okay, sweet. Do one thing. Let's now move it back, and we've restarted it. So now this should work. Should get the tokenizer and. Then with this first part, merge and unload. Next we can ask a question in German. we asked this question earlier, we should get the response. As you can see, all the thinking tokens are now in German. Now let's try another one in Chinese. And we should be good. And it has the thinking tokens here. That's super cool that you can fine tune that. Yeah, let's do something else. Let's do generate. Can you help me understand more about the tokenizer? We'll just dig into the tokenizer quickly. Is this the same as tick token, and can we compare it? Okay, so we're going to compare it to tick token, which was used looks different. Yeah, let's run. I think I already did run it, right? This is the model. Takes my reasoner and runs it. Okay, what are some other things we can learn about the model to compare the diff between the trained and original? The eval set to compare. So after we've done the training, let's just. Oh, it doesn't look like there isn't. It wasn't split. What's the train done? Okay, so we got a validation set. Some eval scores. All right. I did not know Gemini had this. That's cool. This is sick. Huh. Probably one of the best Gemini products I have used so far. So the train set's in this harmony format. Let's see if there's in this format. Pretty slow. I guess that's another thing we can ask it is like to figure out the speed. This is doing 90, but we'll see. No, it's doing 10. Could we get kicked off? It should be faster than this. Okay. Did Gemini get ruined? Nope. This is crazy good. So good. Just going to use evaluate and calculate some scores. Where's the ground truth data from? I think it like finds problems and just keeps going. And I would pay for this. Huh. All this these are just going to all come out as 0, I think. They're all 0s. I don't think it's going to be able to produce an F1 score. I wonder how long it's going to keep going on this. I don't think it generated the actual results. Anyway, let's see. We're doing on time. 1 sec. Let me flip back. Oh, we're going to test the speed. Can we test the speed of inference? Time to first token. Alright, back in 1 sec. All right. Time to first token is 0.09 seconds. All right. Tokens per second, throughput's about 27. Cool. All right, I think I'm going to finish it there. All right. We got there in the end. Yeah, this was interesting to play around with the smaller model. Maybe in the future we'll pick one of the bigger models to do some fine tuning on. We basically took like a model and fine tuned the reasoning into a different language, so that it did the reasoning part in a language that you could choose, which was sort of kind of interesting to spend some time on. We also learned a little bit about just like some of the performance of the model and how it performs. It's interesting that they didn't use tick token. I assume it's just because they used a different tokenizer to train the model, which I thought was interesting. The new Harmony format's sort of interesting as well. Hopefully there's some more data sets that become available that can be used that would help sort of with this process. So definitely interested there to sort of learn more about and spend some time on this. But yeah, this was interesting. I have a bunch of ideas for some other fine tunes that can probably do on this, but yeah, if you spent any time watching me go through this, I appreciate it. And if you have ideas or anything else, let me know. Thanks. Bye.